Hello, my name is Ike McKinley, and this is NOS 220, Linux System Administration. This lesson we'll be talking about backup and recovery. We'll talk about some of the basics of backup strategies, the tar tape archiver, Rsync for remote backups, and a couple of the automated backup systems that are used for regular backups. Most people think that making a backup simply means making a spare copy of your data. While this approach can be sufficient for personal use, it leaves a lot to be desired when it comes to protecting the data on a server or a group of servers. Data on servers changes daily, so backups need to be fairly frequent or risk losing the most recent data. However, a complete backup of large amounts of data can take a lot of time and resources, more than you may want to use on a daily basis. The solution to this dilemma is a backup strategy that uses full, differential, and incremental backups to keep backups recent without excessive resource use or redundancy. So, what are these different kinds of backups? A full backup is a complete copy of all the data that is part of the backup target. Full backups are expensive, so tend to be performed relatively infrequently, say once a month. An incremental backup copies all of the data that has changed since the last backup of any kind, including another incremental backup. This tends to be the smallest and cheapest backup, and so is the sort of backup that we might run daily. However, to completely replace the data on, say, the 20th of the month, using just full and incremental backups would mean that we would have to use 21 backup files. We'd start with the full backup from the first and then add the changes from each day's incremental backup. This is a little bit excessive for doing a restoration, so there's an intermediate sort of backup called a differential backup. A differential backup copies all of the changes since the last full backup. So we could run, say, a differential backup once a week, and then any restoration we might have to do would need no more than 8 files. A full backup from the beginning of the month, a differential from the beginning of the particular week, and up to 6 incremental backups from the days since that differential backup. The exact mix and intervals between backups depends on the amount of data that you have to work with and how frequently it changes. But any large backup strategy on one or more servers should probably use some mix of the different backup levels. So far, we've talked about backup strategies and not much about the actual software you might use to make a backup. The tar command has been the basis for backups in Unix almost as long as Unix has existed. The name, tar, stands for tape archive, and the command was originally designed to copy a small list of files to a tape. It can still do that, but the explosive growth and the amount of stored data makes slow, small, linear tapes a poor medium for backups. Today, tar is usually used with the -F switch to create a .tar file, a single file that contains all the files listed in the tar command. Usually, some form of compression is also used to either gzip with the Z switch or bzip2 with the J switch. The tar command has a lot of options, and even some support for the multiple level backups we were discussing earlier. However, it is mostly designed as a local backup mechanism. What about making backups for remote systems? For remote backups, the most common choice currently available is the rsync command. By default, rsync uses an encrypted SSH connection to synchronize 2 directories. The result is similar to a combination of a full and incremental backup because rsync only copies the changes between those 2 directories. So you get a full backup without having to copy all of that redundant data. There are also commands that let you rename copies with a .backup suffix or place them in separate directories. But if you want to get into complicated backup strategies, it's easier just to use one of the pre-existing systems that are available. The most common system for Linux is known as Amanda. Amanda is based on tar, and all the backup files that it creates are tar files. However, it also has a framework for managing and automating full, differential, and incremental backups from multiple systems. The other commonly available backup system is called Bacula. While not quite as easy to use as Amanda, it does support most of the same features, and is also designed to support multiple backup strategies. Well, that's it for this lesson and for this video series. Today we've looked at different backup strategies and the difference between full, differential, and incremental backups. We've also examined the tar and rsync commands, and we've taken a brief look at the two common backup systems in Linux, Amanda and Bacula.